Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 5-4 in the SavvasRealize Algebra 2 textbook. The goal of today's example is to solve an equation with one radical. So as we get into solving radicals, the biggest thing that you need to remember is that you have to isolate the radical before you can get rid of the radical. All right, so here where I have a plus 1 being added, that has got to go so that I can undo that radical. So because it's being subtracted, I'm adding 1 to each side, and I get the square root of x plus 5 is equal to 4. So now the opposite of this square root that I have here is to raise to the second power. And so I'm making sure to do that on both sides of my equation. So here on the left, the square root and the square cancel out, leaving me with x plus 5. And here on the right, 4 squared is 16. And then for a last step, I need to subtract that 5 to get x alone, and I get that x is equal to 11. Now a key thing with these problems is whenever you raise something to an exponent to get rid of a root, sometimes we get extra solutions which are called extraneous. Okay, extraneous just means extra. All right, and what that extra is saying is that that solution may or may not be a solution to the original problem. So you always need to check yourself so you don't wreck yourself, all right? So here we go. So I'm taking that 11 and plugging it in. So here, 11 plus 5 is 16. Square root of 16 is 4. And 3 does equal 3, so this is definitely a solution. So let's try it again here on the right. So again, you need to get the radical by itself. So to do that, I'm going to subtract 2 from each side of the equation. So I get that the cube root of x is equal to 4 minus 2, which is 2. And then to counteract that radical, again, you're going to raise here to the third power. Okay, I'm just matching my index. Okay. So here on the left, this turns into just an x. And here on the right, I get 2 cubed, which is 8. Okay, and again, we need to check ourselves so we don't wreck ourselves. So I'm taking that 8 and I'm plugging it into the function. All right, so the cube root of 8 is 2, and 2 plus 2 does equal 4, so we are good to go. Now, a key thing here, by the way, I'm going to talk about it here with the square root. A lot of kids remember, because I drill into your brains that when you take a square root, you need to put a plus or minus. Understand that that is only when we're using the square root as a tool. In this case, the square root is already underneath, like already there. They have that. So we aren't using the square root as a tool to solve here. We are just taking the square root. All right, this is a concept called the principal square root. So if ever you have a problem where there's already just a square root there, like you're not introducing a square root into the problem, we're taking the principal square root, which means that we're just using the positive version of it. All right, so now let's get into the triads. So again, with these triads, we want to get the radical alone. So I need to remove the 3 by subtracting it from both sides. So I get that the square root of x minus 2 is equal to 2. And then to remove that root, I'm going to square both sides of my equation. So this turns into x minus 2. And on the right, 2 squared is 4. And then to get rid of the minus 2, I'm going to add 2 to each side, which gives me that x is equal to 6. And again, we got to check ourselves. So I'm going to take that 6 and go back to my original equation and plug it in. All right, so here, 6 minus 2 is 4. Oops. The square root of 4 is 2. and 2 plus 3 is 5, so we are good with that solution. Alright, now let's try it just one last time. So here the root is already isolated, so I'm just going to cube both sides just to get rid of it. So on the left, I have x minus 1, and on the right, 2 cubed is 8. And then I'm going to remove that 1 by adding 1 to each side of the equation, which gives me that x is equal to 9. And so now we're going to check ourselves. So the original equation where x is, I replace it with a 9. So 9 minus 1 is 8, and the cube root of 8 is 2, so we're good to go. Alrighty, so I have solved an equation with one radical. Until next time.